rules. Now, couple things before we talk about what you need to do is you have to make sure that I know you can use photo math for all this stuff. Um, it will work, and you'll get an answer. But I also am going to tell you that if you do that, you will be severely disappointed in your ability to understand the material, and then you'll be severely disappointed in your ability to do well on the test, because I know that photomath can do it, so I will adjust to make sure that I test you in a different way. So what am I going to tell you? You have to know these rules. You have to just learn them. You just have to know how to use them. And so I'm going to tell you, you could do it on Delta, you could do it on photomath, you could do this assignment, but you're foolish if you do. And don't say I didn't warn you, because I'll just go back to this video and look at it. But that being said, to get these rules ingrained in your head, it's going to be really wise for you to write them down 10 times. You'll write them down here, but then once you write them down, then get to another piece of paper and start writing them down again. Because the more you write these down, that repetition will help you immensely. So, the first one, if you have x, and it could be any value. In fact, I'm not going to use x because I worry if I use the same letters all the time, you'll just think that it only works with that letter. Let's say you have a to the n times a to the m. So both of them have a. When you condense these, you can write that a is a to the n plus m. So if you have these two things that are multiplied together, they have the same base, you can add those exponents. If you have a to the m divided by a, let me keep it consistent at least for you. A to the n divided by a to the m. What you do with those exponents to simplify it is you subtract them. So you got two different things on there. One you subtract it, one you add it. Now, if you have a to the m, and then all that's raised to the n power, so you have parentheses surrounding it like that. The way you simplify that is it's a to the m times n. Now, you can have more than one thing in there. You can have, b to the m, a to the n, and then all that raised to the p, let's say. If you have something like that, what you can write it as is you can write it as b to the m times p, a to the n times p. So it's essentially, in that situation, when it's written just like that, and there's multiplication in between the a and the b, you just distribute that. The next thing I would say to you is if you have anything to the 0 power is equal to 1. Anything to the 0 power is equal to 1. Now, if you have a to the negative m, that's equal to 1 over a to the m. If you have 1 over a to the negative m, it's equal to a to the m. So the idea behind that negative exponent rule is if you have a negative exponent, you can move it to the other part of the fraction and make it positive. So that's the way you deal with negative exponents. Right down here is how you handle negative exponents. Okay, so that's how you handle negative exponents. So when you're thinking about how this whole thing works, you just got to make sure you deal with these appropriately. And notice I didn't have a lot of addition or subtraction in here. So don't do this kind of thing with addition and subtraction. So let's take a look at something like this. Let's take a look at m squared and then cubed. If you have m squared and then cubed, that's going to be m, remember this rule up here, you see that rule right up there with, right there at the top, is that means you're going to do a to the 2 times 3 if you're going to simplify it, which on delta math you would make it m to the 6th. Now if I have something like this, find the rule. You got these two bases. Bases are the same. They're multiplied together. So what we do with those exponents is we add those exponents. With that multiplication, we add it, which in this case would be p to the 9th power. Let's take a look at something like this. When we're dealing with simplifying something like this one, you got to take that 3 and put it to both things. So that's got to be 3 cubed n to the 2 times 3. Because remember, that's 3 to the 1st up there. It's not written, but it is 3 to the 1st. So that one, 3 cubed, 3 times 3 times 3 is 27. N to the 6th. That's how you would solve that one. Now, if you have multiplication, just know you can rearrange this. You can rearrange this into 7 times 9 times x to the 5th times x to the 5th. And if we do this one, negative 7 times 9, negative 63 x to the 10th, because you add those two exponents. Okay, that's example 4. Example 5, I think I'd do 2 more examples, 5 and 6. Take example 5 here. Let's talk about the first one. We got 3 q to the 20th. We multiply the 4 times the 5 divided by 5 q to the 4th. Now, we can't do anything with this 3 divided by 5. We can't do anything with that. But remember, this is q to the 20th minus 4. So in that case, it's 3 q to the 16th divided by 5, if you simplified it. All right, last one. Using only positive exponents. Let's look at this one. Remember, this will be 4 squared, z to the 8th on the top, 12 z to the 7th on the bottom. We simplify it a little more. 4 squared is 16 z to the 8th over 12 z to the 7th. Now 16 over 12. What two numbers go into both of those? 4 goes into both of those. 4 goes into 16 4 times. 4 goes into 12 3 times. Now that's reduced. And then this would be z. And remember, because that's division, you would subtract the exponents. So our final answer on this is 4z. You could put it to the first if you wanted to, divided by 3. Hopefully that helps. I don't think I have any more examples. That should get you through all of the problems for today. Go back up, and like I said, don't use photomath. I know it'll work, but that's cheating, and you don't want to be a cheater. And write those rules down. Write them down 10 times. Write each one of them 10 times. If you do, I promise you, they will be ingrained in your head, so when you see a question like this on the ACT, you'll be able to answer it effectively. Let me know if you have questions.